Hey guys, welcome to another lesson with the Infocom Tech Club. I'm Mr. Rias. Welcome back to the new and last term. We will only have 3 lessons for term 4. So I'm going to be covering some other things that we'll be using with Arduino. And then subsequently after that, like the last lesson, we will try to combine some of the different things that we have learned to use to make a coherent project. Okay, so today we'll be learning about using an LCD screen or liquid crystal display screen, just like a small TV, so that we can use it to display some of the variables that we are measuring using our different sensors, and then put it on the screen so that if this was to be a product, it's easier for us to see the values that we are measuring, just like our LCD thermometers and so on, okay, that we are using these days, okay, all right, to measure our temperatures when we are entering different places and so on. All right, so let's stop all this jibber jabber and let's get on to our project. Okay, so in this project we'll be needing a few things. So the first thing we're going to be needing is, because we are measuring our LCD, we are measuring our temperature of our surroundings, so we will be needing our temperature sensor. Okay, this thing called a TMP36, our temperature sensor. And we will also be needing a breadboard, just as always. All right. Okay, to connect our jumper cables and so on. We will also be needing a potentiometer, our old friend, so that we have a knob. And this knob is later on will be used to actually control the brightness of our LCD, just like our TV. We can control the brightness of our TV. Same thing, we can control the brightness of our LCD itself. We need a resistor. Okay, so over here I'm just going to set my resistor. We'll be needing a 630 ohm resistor. Okay, and the last thing that we need, of course, we need our Arduino board over here. Okay, to do our calculation and connect all our sensors and so on. And the main thing that we actually need is our LCD. So if you want to just search under basic, you won't be able to find it. So what I'm going to do is I'm going to change this to all. And then if we scroll all the way down, oops, I missed it. Okay, our LCD, our 16 by 2 display LCD. Okay, a 16 by 2 LCD display means that I have 2 rows. This is the first row over here. If you can imagine, there's a line here. Okay, and every row there will be 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. And then another row of 8. So total I will have 16 characters in 2 rows. Okay, and if I were to later on when we start doing our coding, you will know that the first row is known as row 0, and the second row that will appear in here is known as row number 1. Okay, so for when a lot of times you see in computing, you will start with 0 and then followed by 1. Okay, so let's start our connection with our LCD. So first I'm going to do is I am going to take this LCD. If you were to see a real LCD like this, and it is not an I2C LCD, and I2C basically there's some connection at the back that they have wired for you, so that we do not need so many cables to connect this LCD. But over here it's not an I2C LCD, it's just a normal LCD with all the different pins. Okay, these few pins that we see over here. So I'm just going to take this and I'm going to put it on my breadboard here. Okay, and I put it here so it's easy for us to see. And I am going to put my potentiometer here so that it's nearer. And I am going to make it a little bit bigger so it's easy for us to see all the different points. Okay, so This is where we start first. So let's start with our connections now. Alright, so first thing I'm going to do is I'm going to connect my 5 volt, which is a source of power for all our connections. I'm going to connect to the breadboard here. I'm going to change this to red to signify my 5 volt, and the next one I'm going to be connecting is my ground. Okay, over here, and change to black, so it's for the ground. Okay, now let me just do a bit of adjustment so it looks a bit more neater. Alright, so that's first. Okay, the next one we're going to be connecting our LCD pins here. Okay, so let me just shift this a little bit to the right. Okay, so the first thing I'm going to be connecting here, you can see, is the ground. So I'll be connecting this to the ground of my breadboard here. You can see this whole thing, once I connect to this part of my breadboard, this whole line is going to be ground, and over here the second round is going to be, the whole line is going to be my VCC power. Okay, so likewise my VCC power, I'm just going to be connecting to over here, and I'm going to change this to red. Okay, so this is the power to my LCD. Okay, next I'll be connecting this point here. This is called your contrast. So my contrast is to adjust the contrast on my screen. I want to be brighter or darker, and this will be controlled by my knob over here. So what I'm going to do is I'm going to use this center pin of my potentiometer knob, and I am going to be connecting it to my contrast here. So let me change this to maybe green. Okay, and you can see that for my potentiometer, same thing. I need to connect one end of the terminal to my 5 volt, and one terminal I need to be connecting it to my ground. Alright, so one to ground, one. So for my potentiometer knob, it's already finished connected, and this will be adjusting the brightness of my screen. Okay, the next thing I'm going to do is I'm going to connect this next pin here called my register select. And what I'm going to do is I am going to be connecting this to the pin 8 of my Arduino over here. Okay, and I'm going to change this to a gray color. Okay, over here. Alright, and then the next two pins over here, they say is the read and the write, and the read, write, and the enable. So the read, write, I am going to be connecting this to my ground, and my enable, I'll be connecting this to my pin 7 of my Arduino. Okay, so this is the pin 7 right here, and I'm going to change this color of my pin 7 to brown, which is the next color. Okay, and for the next few pins we are going to leave it blank. DB0, 1, 2. Okay, and we are going to go to, let me count, 1, 2, 3, 4, 5, 6. Okay, we're going to go with DB4, and for DB4 I'm going to be connecting this to pin 6. Yeah, I'll just choose the next color, which is pink. Okay, and the next one is my DB5. I'm going to be connecting this to my pin 5. You're going to choose the next color, which is I mean it's purple, but I'm going to change blue so that there's it won't get so mad. I can see it very clearly. Okay, the next one I'm going to be using this DB6, which I'm going to be connecting to pin 4. Okay, I'm going to be using yellow. Okay, let's adjust this a bit so it looks nicer. Okay, and I'm going to be connecting the this pin DB7 to my pin 3. Okay, let's choose another color, maybe a turquoise now. Okay, so this is for my pin 7. Okay, these last two pins, okay, LED and anode, I'm going to be connecting it to my VCC, my red, to my 5 volt. And over here for the LED cathode, this is where I'll be using my resistor here. Okay, and okay, let me just adjust this a bit so that it shapes a bit. Okay, and I'll be connecting my ground pin here to my ground. Okay, I'll put this black so it's easy for me to see. Okay, let me just adjust this a bit so it looks neater. Okay, so you can see now that I've done connecting my LCD pins all the way to my Arduino. Okay, and what I'm going to do is now I'm going to connect my last component here, which is my temperature sensor. Okay, so the first thing I'm going to do is I will be connecting my power to my board here. Okay, this is my power, and over here is my ground, which I'll be connecting to my ground. I'll change it to black. Okay, so the only thing left is my sensor over here. And if you remember very well, some of our first early projects, most of the sensors we have are analog sensors, so I need to connect it to my A0 over here, which is my analog. I'm going to change this to green so it's easy for me to see. Okay, so let's have a look at our settings now. Okay, you can see that from my Arduino, I've connected it to my VCC here and my ground. Okay, so let me just adjust this a bit because I shifted my breadboard earlier on, and all the different pins that I will need to connect for my LCD screen. Okay, and at the last part where I use my LED cathode with my resistor, and of course I am using my potential meter here on my knob to later on control the brightness of my LCD screen, which the center pin has been connected to my contrast pin of my LCD here. Okay, so that later I can contrast and brighten up or make dimmer on my LCD screen. And of course I will have my temperature sensor here. Okay, so that I can measure my temperature of the room, okay, later on. Okay, so, and this has been connected all the way to my analog pin over here on my Arduino. Okay, so we have done all our connection with our jumpers. So what you can do now is let's start our coding. Unlike the previous projects that we have done, we are using our block codes. Okay, but as some of the seniors who have experienced using coding with Arduino, you will realize that there's only so much we can do with the block code, so there's a lot of limitations. So today we are going to start moving away from the block codes to take advantage of the C++ codes, which if you look at the different codes available online, there's a lot of samples and examples that we can make use of for our projects. So today we are going to be using the codes that come with the LCD library, and also with this TMP36 sensor. Alright, so don't worry, I'll put the codes in our SLS lesson so that you can just go and look at the codes and just make a copy of it and either type it out, or you can just copy and paste into our codes. Okay, so let's go on to our code now. Okay, what you can do first is to click this code over here, and by default you can see that it is our block code. Okay, so I can just go and throw this away if you want. okay, into our dustbin. Okay, and what you're going to do is we are not going to use the blocks. We are going to click this drop down button, and we are going to change everything to just text. Okay, and you will get this message that pops up that say, are you sure? You say yes, of course, continue. And this is what you will see. Okay, first of all, there's some default codes there. Every time when you use your Arduino IDE to do our coding in C++, you will see this. But over here I can just go and delete everything first. Okay, I just use a backspace, so it's an empty place here. So what I'm going to do later on, when I put the codes on SLS, you can just open it up. So let me show you now our codes. Okay, this is our code here. Okay, it's a very short code. You can see that the first part is our setup. Okay, first of all, we need to go and write this part here to include some of the library. Okay, before I go through the codes, let's just do a quick copy and paste. So I'm going to use my mouse to click and select everything. I'm going to right click and copy, and then I'm going to go back to my Tinkercad here, and I'm just going to right click and paste everything. Okay, so you can see all the codes are here. Alright, so let's go through the codes line by line to understand what's happening. Okay, the first line here, it talks about including this liquid crystal library. .h is the library. Okay, so your LCD, the word LCD itself stands for liquid crystal display, just like your TV or your computer screen or even your handphone, your LCD display. Okay, so we need to call this library so that we can use the codes that has already been pre-programmed by before through this library, so that we can go and use it. We don't have to worry what's happening behind it. Okay, and then we are going to use this library to set the variables for this LCD. And you can see over here, LCD, we are using our pin 876543, which is exactly where we are connecting our LCDs to the Arduino. Pin 87654 and 3 over here. Okay, and then over here we are using this sensor pin as a value as an integer, and this sensor pin is actually your temperature sensor pin, which goes to your analog 0 over here. Okay, so if you look over here, our temperature sensor goes all the way to our analog 0, your A0. Okay, and then we can start doing our setup here, and this is basically setting up our serial monitor, okay, at a speed of 9600 bps, our baud rate, okay, so that we can monitor through our serial port later on. And also our LCD, we do our initialization of our LCD, okay, for our 16 characters with 2 rows. All right, okay, and then we go on to our main part of coding. First one is to read our temperature sensor, doing our analog read from our A0 pin, and then we take these values and put it under reading. Okay, and because we are using directly with Arduino, and this is not your more sophisticated humidity and temperature sensor, so what happens is that we need to do some conversion and using the calculation of the 5 volt, okay, to make sure that our temperature is accurate. So I need to do some calculation. First I need to multiply by 4.68, and then I need to do a bit of conversion, okay, by dividing this by 1024. Okay, alright, so after that I'm going to print out the temperature. First of all, I am going to do this calculation to make sure that my temperature is in degrees Celsius, and instead of integer, this value is called your float number, okay, so that I can have decimal points. And then I'm going to read what's in the serial print that is already been set to my serial monitor. And I am going to I'm going to print out for my serial monitor. I'm going to print out the temperature values, which is this temperature C. the variable that has been done the conversion to temperature degrees in degrees Celsius. I'm going to set it out in the serial monitor. And this print line is just to make sure that when the numbers comes out, I have a unit. So I'm just writing my unit in degrees C. And then later on, this is the important part. This is the part that I want to appear on my LCD screen. Okay, so first of all, the first line is LCD set cursor to 0, 0. 0, 0 is just at this point over here. The first pixel of this LCD screen, which is 8. Each row there's 8, so total of 16 characters. So the 0, 0 is this particular one. If I want to go to the next character, it will be 0, 1, 0, 2, and so on. And then the second row will be 11, 1, okay, and so on all the way until 16. Okay, all right. So and then we'll put everything and print it out on the LCD screen. Okay, so that's it actually. So you can see I did not type any other codes. These are readily available in a lot of the examples on the when using Arduino for LCD display. So let's run the code and see what happens now. Okay, so now I'm going to start the simulation. Okay, I can just close this. So you can see that nothing is appearing when I'm running the simulator, but if I were to open my serial monitor over here, you can see that measuring in degrees Celsius. Okay, so how can I see over here? So now what I do is I'm going to use the knob to turn it to increase the contrast. So when I increase the contrast of my LCD screen, oh yeah, see, I can see the temperature value. Okay, you can see the word value is a bit offset here. So you can see that this is the limitation of my LCD screen. It's very small. That's why sometimes when we do our projects, I will get a bigger screen, maybe 20 by 4. Okay, so it's much bigger. I can put in more text over here. All right, so let's see now what happens if I were to click my temperature sensor and I want to, okay, let me go and zoom it out a bit so I have more space. Okay, when I click my temperature sensor over here, let's say if I were to increase my temperature, you can see my temperature in serial monitor it increases and the value on my LCD screen also decreases. Okay, and if I lower the temperature will also go down. Okay, so you can see the word temperature value, I don't like it because it seems to be cut off. So let me stop the simulation. Okay, so maybe I do not want to write the word so long over here. So maybe I will want to write, instead of the word value, or just say temperature and then colon. Okay, and then instead of writing degrees Celsius, I will just write temperature. Okay, Celsius. Okay, so let's start the simulation again and see what's the word that comes out. Okay, so you can see temperature sensors, but it's a bit weird because I want the number to be in front of the word Celsius. So you can just play around with this position. So let me stop this, and I want now, instead of the temperature coming out first, I want the value first before the temperature. So what I'm going to do is I'm just going to do a bit of cheating. I'm just going to change the position. I'm going to remove this and put it here, and I'm going to put the temperature and put it on top. Okay, so that hopefully the position will change. Oh, you can see that when I remove, I forgot to remove the semicolon, and semicolon is very important in coding because it indicates, otherwise you'll have some error in your code. So let's start now, see whether this works. Okay, so you can see that because I changed it a little bit, some of the position is lost. So instead of 11, maybe for the word Celsius, I can change this to, instead of 11, can I change it to maybe 8, 9, 10. Let's see whether it appears. Okay, see what happens. Oh, okay, nothing much has changed, so I need to go. So you can see, you can play around with this position to see where your values comes out. Does it still work when I increase the temperature? Yes, and lower. Okay, so you can see this is a good use of example how to use this display, and you can see for my different projects. For instance, if I were to make my own temperature sensor for the room, maybe like a thermostat, or even if I were to use some sensors that is able to measure somebody's temperature using some thermal camera, infrared camera, maybe I should be able to display the temperature values on screen, so that whoever is using this contraption, they should be able to read the readings easily without having to look at the code. Alright, so this is the project for today. I'll give it a try. Hopefully you can get it to work. I will leave this codes itself on the SLS itself, so when you're doing this project and trying on Tinkercad, you can just go and open that and just copy and paste the code and then see what works and then play around with it. Alright, okay, so have a go. Hopefully you're successful. And if your project is successful, just take a short picture or video of your project working and just post it on SLS to do your submission. Alright, so till the next lesson, keep your feet on the ground and keep reaching for the stars. See ya.